Well, good evening, everyone. My name is Mary DuBois, and along with my co-chair, Maxine Connor, we both are glad that you're here tonight for our June 21, year 2023 Zoom call for the League of Women Voters of Florida Clean Energy Action Team. Tonight we have a fascinating topic. We've titled it Zero Energy Schools in Florida and Beyond. And leaguers are always very interested in their schools, they're interested in their communities, and they're interested in the environment. So here we have a subject that zeroes in on all of that. We have two presenters tonight. One is Phil Donovan, and Phil is with an architectural firm called Little. He's the director of the Regen CoLab. He's going to have to explain what that means. And he's been called a trailblazer in high performance, net zero, and regenerative design. We have a second presenter tonight, Tracy Steward, a mechanical engineer. She is a partner with CMTA, and that's a firm which has been called a unique engineering firm with a culture of innovation and commitment to high performance buildings and zero energy design. Well, we are going to turn the floor over to Philip and Tracy, and then about 5:45, we'll end the recording. And so I'm going to turn it over now to Philip and Tracy.
Okay, thank you, Mary. And can everybody see that?
Yes.
Okay, great. So yeah, Mary, thanks for the introduction. Director of Regen CoLab, that's a fancy way of saying I'm a project architect who thought this stuff should be the norm in architecture and not the exception, and couldn't understand why we weren't doing it, and was working in Virginia. I'm a sixth generation Florida native. So my mother's family were cattle ranchers long before the railroad came down the East Coast. And I left though for a little while, and I went up to Virginia and further degree. And long story, ended up randomly because I was freeing up on a project, getting to work with CMTA on the first zero energy school in Virginia. And at that time, 10 years ago, well, almost 15 now, it was really, I think, the third or fourth zero energy school in the country. And it was the largest. Really was about creating better spaces and places for people and letting this idea of zero energy support and enhance that. So I moved back to Florida about 6 years ago, and we did NeoCity Academy with Tracy and team. And we now have two other zero energy schools in construction, one heading into design, and hoping for many more because it just makes sense. So I'll let Tracy, why don't you introduce yourself a little bit too?
Yeah, so I've been in the construction industry for about 30 years. Ever since I started, I've always been in a space that I've been able to drive energy out and do work that's more sustainable. I started in design about 12 years ago and was involved in the first zero energy school in the country, and then subsequent ones, and we've met up with Philip soon after that. So zero energy buildings, not just schools. I did the very first zero energy police station. I did the first LEED Gold laboratory building. I've done a zero energy higher ed lab, environmental center. So I have a lot of experience doing this, and it's great to work with architects like Philip who are passionate about making the decisions that help us get to that success.
We'll dive in. The last thing I'll say is, there's a lot of, when people think about architecture and engineering, they think, well, there's sort of a master architect and they design this thing and the engineers come and make it work. That's not the case at all with this. So today we're going to talk about these non-traditional ways of doing things, and it's not harder, it's just smarter. And believe me, Tracy and CMTA and our engineers are equals in this process. I learned how to do this work from them. It wasn't something where I was dictating at all. And we uplift each other and all of the clients that we work with and the communities they serve. So that's really important, especially when people talk to architects and you get that attitude a lot. So we have to get rid of ego and move ahead toward a better future. So why is this important? We're in search of a zero energy reality because global resource attrition is creating a catalytic shift in the way we design and construct buildings and operate them. There's a word missing here called operations. That's very, very different in this realm. It's not, again, it's not harder, it's just different. And I saw somebody put in the chat, they were glad they had solar because Duke just raised their rates by 40%. I mean, that's important, right? This is what's happening. Resources are dwindling, and there's more and more people and more demand for those resources. And everybody's starting to look for these things. If you're wondering why there's snowshoes behind me, it's because I'm up in Colorado and on vacation visiting my sister. And this is a state that's starting to embrace that more and more. But Florida is as well, and it's really important that we do that there and continue that push. Buildings use 40%, right? They are 40% of the energy use, and here's the breakdown right here. So that's big in terms of any sort of single sector, and we need to recognize that and understand that we are at the tip of the spear in making change. And it's not a passing trend. You know, studies show that 89% of Americans are very concerned about the environment, whether the politicians are listening or not, and 93% agree that saving energy helps the environment. So it's a win-win, right? We just need to get there. This is a big one. So it's not just about solar panels. I got a call a couple of years ago, right before the pandemic, to see if I could help Miami-Dade County Public Schools because their superintendent at the time said, we're going to put solar on everything and it's going to be great. And we said, yeah, you're absolutely right. It's going to be great, but it's not just about solar panels. I think that's what people think of when they think of zero energy. And so this is that beautiful resort down in Boca where they host the educational facility planners. When it comes down to it, any building is zero energy ready, right? Any building, if you have a solar array big enough, but we all don't have the budget of Disney and others. So we've got to really reduce our energy use low enough in order to make solar work on site renewables. And when we do that, the energy savings alone makes up most of that drive towards zero energy. And this is the other big one. Tracy and I were just talking about this in an interview for a new school the other day, but there's a big difference between zero energy ready. So like I said, I showed that beautiful old building, said this is zero energy ready, right? That's a little tongue in cheek, but in fact, there's a big difference. There's a lot of buildings out there that are designed to be zero energy ready. And oftentimes the owners don't have the capital at that moment to put energy on the building or photovoltaics on the building. And so it's meant to be ready if they are at that point to put solar panels on it to offset its use. However, what I think is missing in that scenario is an understanding of how much operations affect getting to zero energy. And Tracy and I are going to talk about that in a little bit. So this is an image of NeoCity Academy in Kissimmee. This is the state's first zero energy school. And it's a typical Tilwell school, but so there's a lot of these around that are zero energy ready, but it takes a big lift. That school was anticipated to save $115,000 on energy every year, right? But only 23% of that was due to the solar panels. So, you know, they're flashy, they're great to look at, they're really inspiring, but we've got to drive that energy use down and conserve it first. So $89,000 of that anticipated energy savings was from driving the energy use down. And at the end of the day, that building saves $112,000. So we were $3,000 off, but.
And a big thing about that is it's about the conservation first before you buy the solar panels.
Right.
If you can invest in something that saves energy and doesn't need to build a solar panel to offset you, that's where you need to make the investment. It's not as flashy. It's not going to get, you know, all those beautiful photos of it, but it makes a bigger difference because you don't want to build and use solar panels if you can instead just use less energy and then you don't need them to offset what you're doing.
Right. And again, operations, we can design and even construct a great building that'll save a ton of money and be zero energy, but we have to shift the way we operate them. And so that's bringing schools along. That's reaching out to the school districts and the school boards and saying, it's great you're starting to move in this direction, but operations and maintenance are a big part of that. And we'll throw it way out of whack if we don't get it right. And architects and engineers need to be on the hook to help clients and owners understand that. The next big thing about this is the costs are not prohibitive. NeoCity came in under budget, right? So what they were going to build that school for, we were able to do it for zero energy. They could have built it the way they always had, right? On average, zero energy schools use between 65 to 80% less energy. NeoCity Academy was constructed within the state mandated cost per student station. We couldn't go over that or we would have been breaking the law, right? So it just shows we can do it within the means and methods that we're doing it today. If we just do it a little smarter and a little different. And it doesn't take longer to build a zero energy school. Again, we had a 6-month design period for that.
That's really fast, by the way. I don't
Yeah.
know if you've not designed a building, let me tell you, 6 months to coordinate everything amongst all the stakeholders, to get decisions made and get a building ready to construct in 6 months. That's fast.
And that was new. That was new to this market. That was, the team being new to this market and the owner being new to this. And we planned the work and then we worked that plan, and it was a 10.5-month construction period. We're seeing it need to really be about a year to not squeeze it too tight. And our 2 that are under construction, which is NeoCity number 2, which is right next to this one, which will create a campus, and Terry Elementary School, which is an elementary school for Volusia County Public Schools, are both right around that time frame. Both intended to be zero energy. The key to success is an internal champion. This is a big one. At Osceola, so NeoCity Academy is in NeoCity. It's in the Osceola County School District. It's south of Disney, but it's in this development called NeoCity, which is an advanced manufacturing. So they were really interested in this and creating high performance jobs, right? People that may not go on to college, but get out of high school with the skills to work in advanced manufacturing, and they make a really good living at it. And so, sorry, I'll go back one. At Osceola County Schools, we had a champion. We had the director of facilities, Mark Clinch, who since moved on from there, but he put into place standards there that said every new school should be at least zero energy ready, should hit an energy use target, a low energy use target. And that champion uplifted the rest of the team, right? He cleared hurdles and he moved us forward in a positive and productive way.
And another key thing about high performance is that you don't have to compromise the health and wellness of a space. So I'm a huge advocate of health and wellness. And, if you look at the indoor air quality metrics associated with a lot of the buildings, it's very poor. And so there are a lot of ties to how well you learn and how well you perform in a space that is better ventilated with better filtration. And so we at NeoCity actually have increased ventilation. So we have more ventilation to that building to drive down CO2 levels and to purify that air, to clean it, than code requires. And so we actually went through an analysis to say, how much PV do we have to buy to give them more ventilation to this space? And that was a choice that was made during that design process, because the success of those students is dependent on the quality of what their space is, and that includes the air quality. And so there are several studies that are out there. This is the Harvard study on cognitive function, and it shows basically what it did is it isolated CO2, which is something that people thought was just a metric to use as a baseline of other contaminants. But from this, they were able to determine that high levels of CO2 in spaces actually decreases cognitive function, especially in areas like strategy, crisis, resilient, responses, things that where you have to really think strategically. And so we were building a STEM building for the future scientists that are going to be working in NeoCity, and they need to be able to think strategically. And to do that, we really had to look at what our goal was for what our CO2 levels would be. And we used that to determine how much ventilation we would be putting in. And we had to actually get additional solar to offset that.
And what happens when you start hyperventilating, right? You breathe into a paper bag so you can breathe the CO2 and slow your brain down and the rest of your body. I mean, when NASA decided we were going to start putting people in space long term, they went to find studies on how bad CO2 was. We knew it was bad for you, but they could only find it from the compressed gas industry, who said, who sells CO2, said, yeah, you can survive up to 20,000 pp parts per million, no problem. Well, when they set a target of, what was it, Tracy? Something like 6,000 for the space station. And they found that astronauts started slowing down. They got headaches and lethargy, and that they couldn't have that happen in space. So, but you know, below 2,500 is a good target. There's schools out there above 3,000, and we're telling kids, do better, do better on tests, you know, improve your scores, and yet we're not giving them the right spaces and conditions to do that.
And we're trying to keep ours at under 1,000. And hopefully in some areas, we're able to ventilate it to this area where it'll be closer to 900. And then another piece about the health and wellness of a space is daylight. Daylight sets your circadian rhythm. It helps you sleep at night. When you sleep, your brain kind of puts your thoughts back together. I know myself, I have woken up in the morning after I was working on a computer program, and I would know the answer when I woke up, but I couldn't figure it out before I went to bed, because your brain is organizing things in your sleep. So if you're not getting the daylight to set your circadian rhythm because you're in a school that has no windows, I literally was in a middle school with 0 windows when I grew up, and there are some here in Florida as well, then you are not going to perform as well. You're not going to sleep properly. It's going to affect everything. And there's a lot of components to daylight that are even about building orientation, because if the building's oriented a certain way, it saves energy, but it also allows you to deal with glare, so you can keep the blinds open, because they also know that views to the outside are very healthy. And there's a lot of buildings that back in the day, they believed if we had a view and we were a kid outside, we were distracted, and they didn't want to give us that. But they found that that is actually no longer the case. So there's a lot of things within a high performance building outside of the energy component that you really need to pay attention to, that also really have some synergy with energy and quality of space. And these are some of the statistics about learning and how daylight is impacting that within students and student spaces.
I mean, imagine that when we return to nature and operating within harmony with nature and natural systems, things improve across the board.
And there's a lot of issues right now with depression and anxiety and you know, things like that. And really, when you get that daylight and you're sleeping good, you're going to feel different and you're going to perform different. So daylighting and how that impacts the building is a real big focus in design. And so this is an example of a daylight model that we did in Volusia County. And basically what it was looking for is how much daylight do we get in the space? And then there's a separate one that says how much glare do you get in? And so the goal is to get as much daylight in the space, get it as reds and blues as much as you can into the space. But then there's another metric that shows the glare component and to get rid of that. And so we work with Little, and they send us all different window configurations, and we find the optimum one that really gives us a quality space.
Yeah, the traditional method is the architect would draw the windows and send it to the engineer and say, well, these are the windows we want. And the engineer said, okay, well, I'll just increase the lighting, artificial lighting inside, because I typically don't have a role in leading the design of the outside of a building. But I
would just add more air conditioning if I need to, and I just do whatever I need to do to make it so no one complains at me.
Right. I don't get a phone call saying I'm too hot, I'm too cold, it's too bright.
Right. That's usually the goal in the old days. And so another piece about it is I want to explain to you energy use index or intensity. It goes both ways. And that's basically the metric of how we measure the energy. But what we had talked about earlier is, we want to reduce this number first, and then we want to get renewables. And so basically you take, for example, your utility bill, and if you were to break that up into every single thing that consumes energy, for example, in your home is an easy one to relate to. So how much do you use for heating, cooling? How much do you use for your lighting? And some may be in gas and some may be in electricity, but all of that converts to a kBTU, which is a form of energy. It's just a mathematical equation. You divide that by the square foot of the building, and that for 1 year is your utility bill. Okay, so you take the total utilities, kBTU, divided by the square footage for what, and then that gives you your energy use intensity for 1 year. And that's the metric that we use to determine whether a building is doing good or doing poorly. And the lower the number, the better.
Yeah,
Does
like
that
an
make
energy
sense?
bill. Yeah, like a power bill. The lower the number, the better, right? Let's remember that. So EUI equalizes all buildings to one number that we can assess against each other. Oh, there we go.
And it's also important to know that net zero is not it's basically you use energy and you give energy back, but it's not simultaneously. It's basically, you want to explain that a little better?
Yeah,
Philip?
net zero doesn't mean zero EUI. What it means is the building has an EUI of 20 or less is our target, and the rest, that 20 is offset with renewables. So you would hit a zero, but only because,
Right.
or negative, but because you're adding energy back in. So a zero energy building still has an energy footprint because there's months where you aren't producing as much as you're making or as much as you're using. And so it's over the course of a whole year that you have to hit zero energy. So that doesn't mean off the grid right now. I mean, one day it will. Dave was talking about putting batteries in, and that's the real next level game right there.
And we do have some battery power in, most of it set up instead of generators, and switching over to battery for emergency backup, and then harmonizing the grid, which means reducing the amount of peak electricity that you use. So that is definitely becoming a bigger movement in the industry.
Yeah.
And I think I heard somebody say they're doing that at their house, they hope so.
Yeah, excellent. Florida schools are ideal for zero energy. So go out and raise the flag, because we're in a sunshine state, right? And we have predictable occupancy levels in our 50-year buildings. We know most demand comes during the day with schools, right? And when you're making peak production in the summer, guess what? Most schools are out, right? You can really set that energy use down, set it back, and optimize how much you're putting back on the grid, overproducing. And hopefully one day soon, we'll start to see some net metering in this state and some other options for procuring solar. But it also, in any state, really, it becomes a teaching tool. It's another tool in the teacher's toolbox to develop curriculum around. And guess what? We're now seeing these kids who started at the front end of this, LEED and sustainability in the 90s, when it came back again around full circle after the 70s. They're demanding this stuff. They're getting degrees in these things and sustainability, and they're going to be the next ones carrying that mantle forward in the professional realm. Every project is unique. So in Florida, we do prototypical schools, right? And we're trying to convert a lot of our existing prototypes to zero energy. And it's really hard because they weren't designed by architects and engineers to do that. They're not the same. No two buildings are the same. The process to get there, we know through experience how to do it, but we have to optimize according to each site and each building. So there has to be some flexibility beyond a prototype. And you have to use data to guide your decision. So these were actually early energy models from NeoCity. And, you know, CMTA, again, I've been working with them for a long time. So experience and relationships are key. I know, and this is where I get to sing their praises, when we initially sat down to design, we know a baseline. We know that a building should be at around 25 to 20 EUI in order to hit zero energy. And we know how they operate. CMTA has such vast experience in it that their buildings, when they set a target at the beginning and say, okay, we're going to be at a 20 EUI, I know for certain that their buildings are within 1 EUI when we turn it over, because they have optimized it. They know the data. And we run these simulations throughout the entire design process and construction process as things change. So, you know, it all starts with a spark. Somebody like Mark Clench says, hey, we want to do a zero energy school. We want to move our school district in that direction. We meet with the stakeholders and we create design goals and operations goals and project goals for the building. We do energy models that say, hey, this is how much energy the mechanical system should use. This is how much energy the lighting systems should use. And then we make sure that it ties into the curriculum, that it's not just something in the background, but it's an active process in the way that students are learning and teachers are teaching, and then we implement it.
And so what we try to do is we try to look at everything in its category of how can we push energy out. So we'll have a shred on the kitchen and we'll say, okay, these are all the strategies you can use in a kitchen to drive energy out. How many can we work with your staff to convince them that these are ways that they can make food for that district? You know, we'll talk to them about lighting. They have lighting standards. how can we do the lighting design differently that's going to save energy and have you buy into that? The HVAC system is a really big one because the traditional HVAC system we've been doing since 1970, which everybody still loves because they know it, is the hardest move I think there is in getting zero energy buildings, because the highest amount of energy used is the HVAC system. And if you won't stop doing what you were doing in the past to do something different with your HVAC systems and take training classes or invest in training, it's very difficult to get there.
And again, I mentioned at the beginning, operations is the key to success here. We can turn over a building it will work the way it was designed, but that first year of operations is very difficult. And if you have maintenance and operations departments at school districts that just say, look, I don't buy into this, the design facilities team may love it, but we're not buying into it, then that's where we start to see the success really fall away.
And there's always the opportunity to outsource services too. So if there is something that's new, you could outsource it while your staff learns how to maintain it. So there's options that are out there, and we work to explore those with everyone that we can.
It's not harder, right, Tracy? I'll tell you,
it's just
this
different.
stuff is not new. It's not space age technology. These are mechanical systems that have been around for a while. They're heat pumps, just like at our homes. Yeah. It's just on a bigger scale.
They're actually preferred at some districts, that design, and then it's not preferred at others. There's other strategies you can use with the VAV type systems, but you have to modify them slightly. And that little change is hard. Change is hard. We all know that.
I think the other thing to make note of here is we look at this holistically, right? We're talking a lot about energy today, but water stories deeply tied to that. Water and energy are interconnected. You can't separate one from the other, but on a very small scale, we're in Florida. Most of the work of our HVAC systems is pulling humidity out of the air, just making it drier and cooler. What do we do with that water? We dump it down the drain. We pulled out all that water, clean, fresh water. Well, at NeoCity, we took a few $1,000s worth of piping and put it right back into the cooling tower. And we reduced the amount of money we're now spending to pull water in off of the utility because we've got free water we're dumping down the drain. All we have to do is send it downhill a little bit back into the cooling tower.
Yeah, no pumps or anything, just pipe.
No, I mean, this is not new. People have been gathering water and using it for all sorts of things from their site and their buildings for tens of thousands of years. We just got away from that, and we need to get back to it.
And so one of the things we also did was, okay, so if we go to a code compliant building and do the minimum we can, what can we get to? Well, we can get to a 16.5. Most schools, by the way, are 55 to 60. So when you hear 16.5, that's very low. That's in the lowest in the country. But we decided we wanted to increase the ventilation, and that had value to us. And then they wanted, because it was a STEM school, they wanted to add some additional technology to that space. And then they wanted to do some additional scheduling of the janitorial services. And so then we started to look at what impact does that have. And then we put a goal to that, and then we get the PV through the modeling tools to tell us how much to purchase. Now, nothing is ever perfect. So sometimes you run into things during operations where an inverter breaks, or we had actually found out that this tool actually underestimates the amount of PV from the modeling software that was on the market at that time. But that's basically the process that we go through.
Okay.
And then here's some of the metrics, and I'll let Philip jump in here too. But, like I said, 55 to 68 is the national average for energy use. NeoCity's at a 22. That's with utility bills that we gathered over time. And then if you think of life cycle costs, those are usually developed with a small increase in the percentage of the amount the utilities cost. We also work in Texas, and they're experiencing literally a 40% increase in their utility rates since the freeze. Plus even on top of that, so that any of those numbers that they had are way skewed, that they're actually going to get a much faster payback on their investments there on high performance and low energy use.
And what to note here, 22 is before the offset with the solar panels. So that's 75% less energy than a typical school. And when we offset it, it comes down to like a 1.2. it's a 228 kilowatt array. And this is also important. So again, right, any building's energy ready if you have a solar array big enough, but when we pay to mount it on more structure, it costs a lot of money. We're buying a roof already, right? We add some additional design criteria around 5 pounds per square foot in that structure. It's the same roof. This is a TPO roof over a metal deck, just the way they design all the schools in Florida and throughout the country for the most part. And this is a self-ballasted roof system, so there's no penetrations. It's held down by concrete blocks and meets the wind resistance requirements in this location. It's kind of a hand in hand, you know, the roof lasts a little longer because it's protected with solar panels. Again, we don't want to solve one thing. We want it to solve many different issues and be uplifting over time, not to the roof, but it's complex. It's not complicated. And that's a really key thing to talk about. So complexity doesn't mean difficult. It means that there's a lot of pieces that have to come together in the right way, but experience and hard work gets us there. Complication is just something that a lot of people talk about when they hit a wall and they don't look for solutions to get around those things. A big part of the process is getting the air leakage right, especially in Florida. So when we design a building, we never test to see how much air it leaks, and more insulation is a loss of value to a certain point. So you're just spending for more insulation, spending money necessarily. So
especially here in Florida, in cold climates, you want that insulation. Florida,
no,
it doesn't pay.
But what we don't want to do is have warm air infiltration or leak all our cool conditioned air out, right? And so when we do that, and then we test the building, which is pennies on the dollar at the end of construction, it's a blower door test to say, yep, the building leaks this much air. Our mechanical system is sized to handle that amount of air leakage. Then we pull a lot of money out of first costs up front, right? Because up to now, engineers have designed in, architects say, yeah, it's going to work great. And engineers go, well, we're going to add a lot of redundancy in because we don't know and we don't want phone calls. So
yeah, typically when we hire people, I notice that usually the sizing of equipment with a non-tested building is 20% to 30% more capacity because of the fear associated with it having building leakage. Infiltration is a number you put in, and it gets pretty big if you have zero confidence in your envelope.
And why? It's such a simple thing to do at the end of a project is to test a building. And we build schools out of concrete here, right? That's the greatest air barrier you can find. If we can then just get the joints right between windows and walls, and that there too, and we're going to get into that. Here you go. We take a belt and suspenders approach. We're 40 miles from the Space Coast. We didn't send humans to the moon with one system. We sent some redundant systems. Well, with these schools, this is a joint, a drawing of a joint in plan between two concrete wall panels. All we did here was add some redundant sealant. It's stuff you can find at Lowe's. Everyday low cost things. But when we put them together, we get 5 layers. When one fails, the other one's intact, and we know we're not leaking the cool air and letting warm air in. So redundancy in a simple and low cost way adds up to high performance. And then, right, I can draw this really well all day long, but a lot of this stuff is just dashes, right? You see down there on the bottom, that's a dashed line is what is shown as this blue tape here. And to install that piece of tape, it's 6 steps. So we got to show our construction partners the right way to do it. It takes 6 steps to install that. You need to prime the joint, you need to put the tape on, you need to use a weighted roller. So we help them find success through quality control manuals in construction. And this is just follow the steps one by one. And what we do is this contractor printed this out, and everybody on the job knew everybody else's job, right? So when the drywall installer came up to this joint here on the bottom right, they knew if they didn't see blue tape there, they raised their hand and say, hey, I don't think you want me covering this with drywall because it doesn't look right. And when they did that, we tested the building and we passed it first time. We talked about whole building testing. We built a mock-up first. And again, this was pennies on the dollar to ensure where we made mistakes in this new way of doing things, we messed up on the mock-up, got it right there. And then when we did it on the building, for real, we passed the air leakage test first time. So we had, NeoCity Academy has over 73,000 square feet of building envelope of walls, exterior walls and roof and windows. We set an air leakage rate of 0.15. That's lower than code. So code lets you leak 0.4 cubic feet per minute out of the envelope. Army Corps of Engineers says, let's do a little better. That's 0.25. Working with CMTA, they said, if we want to get to zero energy, we want to lower it down to 0.15 cubic feet per minute. Well, when we tested this building, we got to a 0.027. And we
Wow.
averted, I think, 40 tons of additional cooling load.
Wow.
It'd be like putting a 40-ton air conditioner out in the parking lot and turning it on just for fun.
And your house has probably 3 to 5, so.
Yeah.
Yeah.
So you can test your houses too. There's ways to do that out there. There's people who do that testing, and when, you know, a lot of times it's just some sealant that would help reduce your utility bills again. But, you know, we talked a little bit about it before. Design is only 50% of the process. So I think Tracy's going to talk a little bit.
Yeah, so basically it is, you know, basically you have to have that champion, you have to have that requirement and that goal at the beginning. Then you have to get through construction and estimating, and then you got to build it, and then they got to operate it. And so there are many opportunities to fail on that path towards zero energy.
And I see a question in the chat. That was, it's called a blower door test for your house. And they just come zip a fan into the door of your home, and they try to suck air through and push air through. And they go around and tell you, well, here's where you're leaking. And we do that on the commercial buildings too.
Mhm.
And as Reagan famously quipped, trust but verify, right? In construction, this is us testing the mock-up. And what we found was that black wall there is part of a stucco installation system. And when they screwed all those screws in, they penetrated the air barrier, which was fluid applied, and then they used some foam to hold the insulation up. Well, that foam expanded like the great stuff we use in our homes to fill gaps, and it pulled the screws out through the air barrier. So when they pressurized it, we had a chimney, right? We had all these little tiny 57 little chimneys blowing air through. And that was just the way they always installed that system. But we had them take it down and redo it. And they wanted to do it the right way. Nobody had just shown them how. And when they did it, we passed the mock-up to a better testing standard than the building. And then we did it again on the building. And we do air leakage tests, and we do water leakage tests. That's a big airplane motor right there on the right, and we blow water at 75 miles an hour at that window for 15 minutes to see if it leaks. And we had almost no leaks on that building. There were a couple in some strange areas, and we fixed them and passed the testing, the blower door test, the first time on the first try.
Amazing.
So you also run into, like we said, those barriers. Commissioning is where they test things and how things operate when you're starting up a building. And so part of that process identified several things. The other thing is we had surprises in the operations. And so some of our goals that we have and things we put in our models, we have to know how often you're going to be running things, because it's just like anything else. How often you run your air conditioning is going to affect your utility bill. And so these are some of the things that impacted some of our numbers at NeoCity.
And I think this is really important because, again, we turn it over and that building's got a 50-year lifespan minimum. And the owners and the operators need to understand the decisions they make will impact it, will impact how the building's performing. But you know what? This building it was the first to come back online after COVID.
Mm-hmm.
So they were
Right.
the highest reattendance rate following students coming back into school. And I believe, Tracy, you have to correct me if I'm wrong, but we over-ventilated. It was a building set up for a pandemic no one expected. We were able to over-ventilate and only pay a 1 EUI penalty in energy use. So
yeah, we increased it even from where we were before.
Yeah, and the way it was designed is that we could ventilate one space, move students out of one, and ventilate that space while they occupy another. And most schools, you lose a whole wing because you're sucking all that air through the whole wing or through each space as it goes along. So what are you doing? You're contaminating each space as it goes through. So it really does create high performance opportunities to deal with conditions that we don't even often know about. The other, Tracy, I'll just add one last thing in there. This is a story I forget to tell sometimes, but this is a great one for Tracy and I. So we opened this school in August of 2019, and in February was the first cold day that they needed heat. It was mid-February and it was 32 degrees that morning. And as architects and engineers, we are constantly looking at the building automation system, telling us how the building's performing, all the different systems. So we're in there because we learn, right? We learn for the next one. We don't just rubber stamp it. So Tracy calls me up this morning, this certain morning, saying, "Oh my gosh, we're at freezing temperatures outside and the heat didn't come on. We're going to get phone calls and we're going to be in a whole hot mess." Well, we did call them, and the principal didn't know what we were talking about. He said, "No, we're here. We're fine in the building." Well, what happened was the building maintained its heat from the night before. Why? Because we're not leaking air. And when you get the students in there, all those warm bodies brought it back up to temperature. So we got it corrected immediately. But again, there's resiliency built into these projects, and that's important.
And this is an example of something that actually happened here and at my zero energy police station, where we ran into an inverter problem. And the ability to be able to look at things remotely makes a huge difference on your ability to find out when something goes wrong and to address it quickly. And so basically we found an inverter problem and we were able to get that addressed to get us back in line.
Yeah, and this is new. This is new systems. They're not used to looking at inverters that might be down. So we have to help them. And you know what? Ask your architects, ask your engineers, how often do you go back and look at how your buildings are performing? We go back all the time, and that data is gold to us. When we go to the next one and talk to the next owner and they have issues, we can say, "Well, have you tried this? Have you looked at this?"
Right.
And we learn just as much for the next one. And at the end of the day, this is what success looks like, right? That's a beautiful roof. The other thing we wanted to touch briefly on today was
I think we need to be brief. I think we're running out of time.
Yeah.
Okay. Yep, we'll wrap it up. So this
Mary's
is
very nice not to call us out.
yeah. So this is we have NeoCity number 2, which will finish off the high school campus, is under construction right now next to that building. And then this is an elementary school in Volusia County. It's a community school. All these children have been bused out of this historically African-American community, 45 minutes, and we're now creating them a zero energy school to come back and learn. And then, it's all tied together. Health is deeply tied to energy, to water, and social equity. So I'll just flip through these for the TURI, but again, optimizing on site, orientation of building program is key, studying it, and this one should be open for next school year in 2024, and it's anticipated to save $252,000 a year. With that, we'll take questions.
All right. Well, thank you very much, Tracy and Philip. What I'm going to do now is close the recording, and then we'll pivot to questions. Yeah.
Sounds great.
All right. So
Thank you.
here we go. Let's see.